We're going to refine our definition of a salt. A salt is a substance in which the hydrogen of an acid has been replaced by a cation. So a cation is going to be a positively charged ion. And so if I took something like hydrogen chloride and I replaced the hydrogen with a cation, I would have a salt called sodium chloride. I've always taught it to you as being the positive and the negative ion together makes your salts. An ionically bonded substance is a salt, but we can look at it as thinking about the acid losing its hydrogen and being replaced by a cation. And this is true of any salt. So we could, for example, say if I took sulfuric acid, H2SO4, and I added it to potassium metal, I would land up with potassium sulfate and some hydrogen gas. These equations you have been exposed to in grade 9 and grade 10 and now again, so you should know them. An acid plus a metal is salt plus hydrogen. An acid plus a metal oxide is salt plus water. An acid plus a metal hydroxide is salt and water as well. And an acid and a metal carbonate is salt, water, and carbon dioxide. The salt always being the acid with the metal cation having taken over its place. Let's look at specific examples. So if I had potassium and sulfuric acid, I would get potassium sulfate and hydrogen. Aluminium and nitric acid, aluminium nitrate and hydrogen. Metal, acid, sodium and phosphoric acid, sodium and phosphoric acid gives you sodium phosphate and hydrogen. Magnesium and nitric acid give me magnesium nitrate and hydrogen. And finally, silver and sulfuric acid gives me silver sulfate and hydrogen. I'm not sure if that one would work very well because actually silver is less reactive than hydrogen, but in theory, there you go. It's another example. If I've got potassium oxide and sulfuric acid, I get potassium sulfate and water. Aluminium oxide and nitric acid, aluminium nitrate and water. Again, the general reaction, metal oxide and acid, gives me salt and water. Magnesium oxide and nitric acid, magnesium oxide, magnesium nitrate and water. And sodium oxide, sodium phosphate and water. Balancing each equation. Remember to double check how you would write the formulae of those salts, remembering exactly what the valency is of each of the parts of the salt, the cation and the anion. Potassium carbonate and sulfuric acid. Potassium carbonate becomes potassium sulfate and then water and carbon dioxide. Aluminium carbonate and nitric acid, aluminium nitrate, water and carbon dioxide. Sodium carbonate and phosphoric acid becomes sodium phosphate and water and carbon dioxide, and magnesium carbonate and nitric acid becomes magnesium nitrate, water and carbon dioxide. Again, check the valencies to get the right salt formulae before trying to balance the equations. Now we're going to look at a concept called hydrolysis. Hydrolysis is an acid-base reaction in which water acts as either the acid or the base, usually salt dissolving in water. So we're going to look at what happens when we dissolve various salts into water and what type of a solution we get. And I just see this as a tug of war. It's really easy. If I take a strong acid and a strong base, they are going to land up fighting and they'll get a pH of 7. So that salt will have a neutral pH. If, however, I take a strong acid but a weak base, then this acid is going to win and I am going to land up with a low pH salt, for example 5. If I were to do the exact opposite, the weak acid and the strong base, the base wins and maybe the pH of my solution is going to be 8. If I were to take my weak acid and my weak base, it's a pathetic tug of war, but the point is the winning team is nobody and the pH turns out to be 7. Let's look at this by example in a little bit more detail. So as I dissolve various salts into water, I need to look at what type of acid or base would have contributed to that salt. So if I take ammonium chloride, where did this come from? It came from the base, ammonia, and the acid, hydrochloric acid. Hydrochloric acid is a strong acid. Ammonia is a weak base. So that would mean that this particular salt, ammonium chloride, if I put it into water, would create a slightly acidic solution. Let's try the next one. Sodium nitrate comes from sodium hydroxide and nitric acid. Sodium hydroxide is a group 1 hydroxide, so it's a strong hydroxide, at least a strong base, and the nitric acid is considered a strong acid. So you would land up with a neutral salt. Sodium nitrate is a neutral salt. If I take something like magnesium hydroxide, that is a weak, let's just draw it out, it's MgOH2. Magnesium hydroxide is a weak base. Ethanoate comes from ethanoic acid, which from your organic chemistry you'll remember is CH3COOH, and that's also a weak acid. So we are going to land up with a neutral endpoint because weak and weak land up neutral. Let's take potassium, would have come from potassium hydroxide, which is a strong base. Sulfite is the SO3 ion, and that comes from sulfurous acid, which is a weak acid. Therefore, we get a basic endpoint. Why? Because the sodium hydroxide wins the fight.